In this video, we're going to be graphing rates from a table. So often you'll see your unit rates presented in that equation. You can fill in a table and then using the x and y values, plug that in to a coordinate plane because we know that we can plug in points using x and y values. So according to our equation, our unit rate is 6. So any value of x is going to be multiplied by 6 to get our y value. So if I plugged in 1 for x, 1 times 6 is 6. If I plugged in 2 for x, 6 times 2 is 12. 3 times 6 is 18. 4 times 6 is 24. And 5 times 6 is 30. Now that we have our chart filled in and we know what our x and y values are, we can plot those on our graph. Now our graph does not have any values listed for the x and y axis. That's because our values don't increase at that kind of same rate. X increases by a value of 1, but y is increasing by 6 each time. So when I start at my origin, I'm going to write out my scale just a little bit differently. So I'm still going to increase by 1 on the x-axis because I know I'll end up at 5. But on the y-axis, my scale could be by 2s, by 4s, by 6, and it'll still work when we plot this out. I am going to actually go by 2s, so I'm going to say 2, 4, 6, 8, 10, 12, 14, 16, 18, and then that would be 20. Now ours goes all the way to 30. That just means that a few of our ordered pairs won't end up on the coordinate plane. But because we have a constant rate, we can see and predict where that line would eventually go. So let's plot our first ordered pair of 1, 6. X, then y. So we go over 1, up 6. 2, 12. So I go over 2, up 12. 3, 18. Over 3, up 18. And you can see we have a very straight line going from our origin. So if we were to plot this, the 4 value, it would be about there. Off the chart for sure, but we can see this relatively straight line because I can't draw straight lines, heading towards that 24. Same thing for 5. If we kept this line going and we ended up at 5, we'd be way up here.